All right. Before we get into new stuff, let me do one little thing here. I'm not looking young. If all I ask you for from this is find the vertex, and that's like the only question. Or I say find, what would it be in this case? Would it be a maximum or a minimum? Some of you guys are like 50-50 shot. They both start with M. I'll just say, no, that's good. Which way does it open? Down. So that's going to be a max. It's a hill. It's got a top. How would I do that? Yes. So the vertex, the quick way to find it is negative b over 2a. So what do you get for that? What's b? 70. So negative 70 over twice negative 7. $70 divided by 7 is 10. Divided by 2 is 5. And the negatives cancel, right? Or you can do 70 divided by 14. It's easier to do 70 divided by 7 than divided by 2. Is everybody cool with that so far? Okay. Now, that, of course, is not the vertex. That is what? The x piece of the vertex. That's why you always tell yourself what you're doing. Don't just write that, because then your brain goes, oh, I'm done. Do that and go, shit. I got the x piece, I need the y piece. How do I get the y piece? Yeah, that's the x. How do I always get the y? Plug it in. So what's f of 5? So you're negative 7 times 25. Is that cool? Plus 70 times 5 minus 5. Let's see, 35 times 5. Oh, it's 175. 170, I think. I love how you guys know. Sure. Is it 170? Yeah. Yay, alright, cool. So what's the vertex? 5, 170. I love it. Alright, now, before we leave this. So if I just say find the vertex, my gosh, do not complete this thing squared. Alright? That is a shortcut. We call it a shortcut for a reason, because it cuts past all the shit in the middle. Now, if I do get, like it did on the test, if I say put this into what I call standard form, into a, if I say do this, I already know what the answer should be for the vertex. So do you understand? If I said do this to find the vertex, if I were a student in this class, I would do this first, so I knew what the answer was supposed to be. So I could quickly tell if I was going off track. Right? So how do I start this process to put it into this form? Yeah, pull out a negative 7. So I get x squared. Yeah, minus 10x. Minus 5 over there. And then, most of you guys get this process, the two-step process, but then you're not sure what to do with what comes out of that process. First step, of course, is cut 10 in half, negative 10 in half. Second step is to square that bad boy. What do I do with 25? Yeah, add 25. Now I don't subtract 25, do I? Because I didn't just add 25, and that's where students are like, all right, I knew this guy was loopy. He just put plus 25 himself. No, I didn't. I just did negative 175. So I better, if I just subtracted 175, I better add 175. I like it. I like it. So now we get negative 7. How do I factor this? X minus 5 squared plus 170. Does it verify what we saw up here?
Yep.
5, 170, kick ass. Right. That's what X equals, make it all official. Cool. I like it. Okay, that's enough of that. That's enough of that. So, what's the y-intercept of this? 0, negative 5. Yeah, that's officially enough of that. Okay. Alright guys, so Chapter 11 will of course be on the final, but for right now, if you absolutely hate Chapter 11, delve into this one completely, right? Just give yourself a little break from Chapter 11. How many people have worked with logarithmic functions, logs? All right.
Thank you.
All right. So don't worry. If you haven't, we're going to do it. If you worked with it before, it made no freaking sense at all. I'm going to hopefully make sense out of it. We're not quite there yet, so let's kind of build up. Bless you. There's a leftover idea with functions that we sort of put here, because this is sort of the first place we really use this idea directly, and that's the idea of inverse function. So what's your gut tell you would be the inverse of a function that involves addition? It would be a function that involves subtraction, because inverse means opposite, right? Like the additive inverse is what you add to cancel something. The multiplicative inverse is what you multiply to cancel something. So it's all about cancellation. It's got to be the opposite thing. How are we doing? All right, so we're going to build up to this idea of inverse. So this sheet is all about building up what we need to know before we can talk about the inverse directly. So the very first thing we got to talk about is something called composition. This is not English class suddenly. It's composed of more than one thing. So if you have a compost pile, anybody ever done a compost pile? Some of you guys are like, what are you talking about? I live in the city my whole life. Compost pile is composed of many, many different things organic things that can then break down and be used as fertilizer, whatever. All right. So the idea of a composite function is that it's a function that's made of two other functions. So this notation is, personally, I dislike this notation. It's unnecessary. Students identify with it because it's how they feel, like they're in a fog. But to me, this is all we need to know, is when I see this, it really means this. So let's review something very quickly. Before you even do any of these problems, look at these functions right here. So right here, I want you to tell me, what is g of 2? 7, right? Because what's the idea of a function? It's just substitution. When I see function notation, I take that thing and I plug it in, I get 7. So what is f of negative 1? Yeah, so I plug a negative 1 into f. Negative 1 squared is 1 times 4 is 4, minus 1 is 3. Just want to make sure you guys remember how function notation works. Now look at this first thing. Good old fog function. What's a better way to write that is this. So if I'm you, when I see this, I'm going to write it like this. Now how does that help me? Well, tell me this. When you're simplifying an expression, let me show you. If I had to simplify this expression, where would I start? If I had to simplify 4 minus 2 times 7 minus 3 plus 5 squared, where would I start with that expression? 3 plus 5. Whoever said distribute the square, just stop the square can't distribute across the district. I'd start with the innermost thing, wouldn't I? I almost don't care what's out here. I start with what's in there. If I keep doing that now, there's nothing there. But so where am I going to start? I'm going to start with the inside. What is g of x? What is that? What is g of x? X plus 5. What is this saying to do? What is this saying to do? Put a 2 into g. Do you see how the way we write it actually makes sense? Where is the 2? It's in g. What do I want to do with the 2 then? Put it into g. Right? What do I want to do with the negative 1? Put it into f. Why? Because it's in f. So what do I want to do with g? I want to put it into f. The idea doesn't change. If it's a number, I put the number in and I solve it. If it's an expression, I put the whole expression in. So g of x is x plus 5. And what does f do to anything that's in it? This would be 4 times what? 4 times x plus 5 squared minus 1. Stop there for a second. Because what did we do with that negative 1? Didn't we put it into 4 times negative 1 squared minus 1 and then solve it to get 3? We put negative 1 in. Whatever's inside, I replace x with it. How are we doing so far? Is that decent? And then I can simplify this a little bit. How do I simplify this a little bit? Squared, that's right. So I get x squared plus 10x plus 25. So then I get 4x squared plus 40x plus 100 minus 1 is 99. So that is the f of g function. Okay. So, is that cool? It works exactly the same. If I put a number in, I put the number in. If I put anything in, I don't care what it is, I put it in and then I do what I can. Now what about this one? How would I rewrite this one from the beginning? G of f of 3. So what do I have to figure out first to start this off? Where do I start when I'm simplifying something? I love it. So I can figure out what f of 3 is, and then whatever that is, I can put it into g. So how do I figure out f of 3? Plug a 3 in there. So when I plug a 3 in there, I get 4 times 3 squared minus 1. What is 4 times 3 squared minus 1? Yeah, so you get 9 times 4, 36 minus 1 is 35. Right? So I work on the inside like I always have. I start on the inside. Now I know what the inside number is. I can take that number and put it into g. And what does g do to stuff?
35 plus 5.
Yeah, it'd be 35 plus 5. Bam. So it's really kind of nice when there's a number here instead of a letter, because then you can kind of get a number and then work with that number. It's all numbers. When it's not a number, when it's a little expression, you just put that whole thing in and work with it. You're not going to get a number answer. Now this is the one that really, really freaks people out, and I don't blame you, but it works the same way. What would you figure out first here? Yeah, to figure out what f of negative 1 is, we already did, didn't we? What is f of negative 1? 3. So the inside, f of negative 1 is 3. And then what's f of 3? We did that one too. 35. So this is 35. So it's the same thing as always. It's awesome. Order operations still follow. Do the inside first, and then go out from there. This is something you can kind of sink your teeth into a little bit better, I think, than the last chapter. Yes, ma'am?
Do you take that 35 from
No. There's only 2 f's, right? So what is f of negative 1? It is 3. And then what is f of 3? It is 35. So is there any more f's telling you to do more stuff?
like
Is there a G in the question? Nope. Where am I at now? Why did I know I wasn't done at this step? So I did the inside. Right? F of negative 1 is 3. How do I know I'm not done yet? Because is there more I can do? What is this asking me to do? It's asking me to put 3 into F. And I do that and I get this. Now what is this asking me to do? Is this asking me to do anything? What is this? This is a number. It's not asking me to do anything, so I know I'm done. Let's try a couple more here. Let's do some more, some different functions. You guys try this one, number 4. Don't overthink it. There should just be like one step for this. Yes? Mm-hmm. So what am I plugging into K? H, and H is 1 over x squared. And here's what K does to stuff. K doubles whatever's inside of it and then subtracts 3. So what is this going to look like now? 2 times 1 over x squared. Yeah. And if you wanted to, you can write this as 2 over x squared minus 3. That's all you need to do. There's really nothing else you could do. You could get like denominators, but that doesn't really do much for you. What about number 5 here? How can I rewrite this for myself so it makes a little more sense? So when I see this, when I see K of 4, it represents a number. It's a number I don't know yet. So what am I plugging into H? I don't know yet. So I better do that first. That's why I started on the inside, so I know what the hell I'm plugging into H. So how do I get K of 4? What do? 2 times 4. Just plug a 4 into K. Minus 3. So it's H of 5. And what does H do to stuff? Yeah, 1 over 5 squared, which is? I know I'm done because all that's left is a number. And the number is not asking me to do anything. The number 7 isn't saying something to me. 7. Oh, I got to go do this. What? H of 7. Oh, shit, I got to take 7 and put it into an H. Figure it out. Okay, I like it. So this is really like if I said to you, there's K right there, right? You guys are all like, why are you covering that shit up? There it is, right? We got that. Here's K. What if I said plug 7 minus 2 into K? Plug 7 minus 2? So then you'd go, oh, so you really just want me to plug 5 into K. You guys see that? I was just being silly, and you plug 7 minus 2, and you're like, all right, so you want me to plug 5 into K, that's what you're saying. So this is saying plug K of 4 into 8, and you're like, all right, what the hell's K of 4? You want me to plug that stupid thing in. You guys get that? You can see that? It's just one extra layer. I'm not going to tell you what this is, but whatever it is, I want you to plug it in H. You're like, all right, let me figure out what the hell it is. Oh, plug a 5 in, sweet. Okay. One last problem, and I'll let you out. How do I rewrite this? Now, in this problem, do I give you any functions to work with? No, I give you this table, which is better. Students see this and they go, what the shit? But I don't have to do any work. The work's been done. What's a table mean? It means somebody's already plugged numbers in and gotten numbers out. They did the work for me. What is G of 5? So for an input of 5, what output did they get?
2.
All over the place. 4 would be if I use the function f. This says what? G of 5. So for G, with an input of 5, 1. You guys see that? This is the x, and these are the two y's. This is the outputs for the f, and this is the outputs for the g. Which outputs do I want right now? G outputs. For which input? 5. So this becomes f of 1. And what's f of 1? Yeah, when you plug a 1 in, I get a 0 out. Bam. Do you guys see how that's actually better? They've already done the work. You don't have to square and subtract. You already did it. Whatever the hell it was, they did it. All right, that's enough right there. You guys are like, please say the magic phrase. All right, I'll see some of you guys in a few minutes in the lab.
He says it's hard to understand.